let's dig a bit more into that kind of that idea, this Git version control kind of topic.
Yeah.
So version control tools like Git, these were built for software engineers originally, but data scientists are using them regularly today. Do you think that it's like ideal for data scientists? Do you think this thing's missing?
Well, I do think version control is ideal for data scientists. So let's start there. We want to have some version control, right? We built a model, we deployed it, then we changed it, then we redeployed it. We need like the old one can't be lost. That's not the answer. There are a couple of things that are challenging about Git for data scientists. Number one, the models themselves are typically very large objects, right? I've seen these big neural nets be hundreds of megabytes or gigabytes. You could get, and up from there, right? And if you look across the industry at other adjacent industries that have very large assets in their version control, they typically don't use Git. Git is notably bad at large binaries. And so the video game industry, for example, will use like Perforce, right? But in the tech industry, that is not generally going to be an option because there's an army of software engineers at your company and they're using Git and they're using GitHub or GitLab. And so we want to be in GitHub or GitLab. So that just means what Modelbit will do is it'll be backed by Git and it'll interact with your Git account, but we will stub the large files in Git and replace them essentially with a metadata file that specifies their signed URL in S3. And so that's just a little improvement that we make. The second and
Gotcha.
more interesting, go
So,
ahead.
so that means, so this idea of stubbing, it means that it looks and feels to the user on the front end like they're just using Git, but in the back end, there's some cleverness that
Mhm.
is referencing back to like an S3 bucket in AWS
You
and
literally
storing it.
you literally just run git push and we'll notice a large file, put that metadata stub in, upload the large. I should specify these things in order. First, we upload the thing, then we get the pre-signed URL information. We put that in the Git. We check it in. Great. And then when you git pull, the process happens in reverse. As part of the git pull, the file gets downloaded and put in the local file system. So that's sort of a quality of life improvement that we make. You get to version control your models. You get to put them in your GitHub and GitLab account in the same place as all your other code at your company. Everybody can collaborate on it. You can do all your GitHub actions. You can do merge requests and branching, and it all works. But we don't bog down your Git repository with huge binary files. So nice little win. I also think what's important is, calling back to modelbit.deploy from a notebook. You're developing your model in a notebook. Checking in the IPyNB file itself is like annoying. They're just not amazing in Git.
100%. Yeah, because you end up with very small changes that you make to the Jupyter notebook will end up
The
being these
whole thing.
huge apparent changes. Yeah, you're recommitting the whole thing. Yeah, exactly.
So some companies prefer to have the notebook itself also in Git just as a management thing, so you can get it, which is fine. But in terms of version controlling the model and the model code, it's not the right metaphor. And so when you call modelbit.deploy from the notebook, the code of the model, usually there's a bunch of Python code that does like feature engineering and input checking and things like this. That code, as well as the model itself, get put into Git as source files rather than the IPyNB file getting put into Git. And so that's really nice from a model versioning point of view. So what you see is a clean diff of the actual model code. And if you roll back,
Right.
you're rolling back the model code. You're not rolling back the notebook.
Mhm.
And the notebook persists as this kind of experimental interface. So that's really cool too. And the upshot of all that is that Modelbit is not actually backed by some multi-tenant MySQL database. It's backed by your Git repo. So when you go to app.modelbit.com / your company / whatever, there's a fetch from a Git repo that happens that powers what you see on the screen. And then when you make changes in the app, that's a commit that's made to the Git repo. dbt also notably works this way. And we found it's really nice sort of workflow for data professionals.
Very cool. That sounds really good. And so a while ago, I don't know if you have now ventured onto this, but you had like a number one, and then I interrupted you and dug into the stubbing. And just
Oh
as you were
yeah.
saying, number two.
So to bring us back to the table of contents, I think number one was the sort of stubbing, which is at the end of the day just a quality of life improvement, but we're proud of it. And then number two is the way the notebook and the web application interact with your Git repo, which we think is maybe more strategic.
Nice. Very cool. Yeah, that does sound like a nice way of interacting with these notebooks that, yeah, I'm, it makes for me, because I just take Jupyter notebooks, these IPy NB files, and for my teaching stuff online, for example, I have these GitHub repos where the Jupyter notebook is. I make this tiny, like, I'll change a lowercase letter to a capital letter in one of the
Right, and then
notes in the
the whole
notebook, and
JSON representation
exactly.
goes crazy. Yeah,
So then
it's
I end up
nuts.
getting, but it makes me feel like I'm making these huge commits, because it'll be like, you changed 10,000 lines of code. Um,
I like that, right? I still get to check in a little code every now and then to Modelbit. Probably not a great use of time, but I'm just hoping that 5 years from now, when we're a big company, the engineers will see me in the Git blame still, and I'll get
right,
some credit from
exactly.
them. You know? Yeah.